Hello friends, good morning. Yeah, it's morning 5:50. Okay, let us start new chapter IPv4 addressing. In IPv4 Internet Protocol, there is two versions of Internet Protocol: IPv4, IPv6. In IPv6, there are some points: variable size packet. IPv4 is a variable size packet due to options which IPv4 header packet we have already learned in previous videos. Then time to live, there's live, LIVE. Okay, time to live or header checksum. In IPv4, it says it is fixed in size 40 byte. Next header field, hope limit, time to live same as time to live, hope limit, or no any checksum. In IPv6 there is no any checksum. Let's do see IP address, unique identifier assigned to a device. Okay, so here the IP address have two sections. IP address have two sections: network ID or host ID. Okay, and the size of IP address become x plus y. This section called x bit and y bit, total called x plus y bit. Okay, x bit for network ID and y bit for host ID, both become x plus y bit. So the size of IP address is x plus y bit. So now we see network identifier. Network identifier is a x bit range string assigned to each connected network and managed by INA, Internet Assigned Number Authority. The network ID is managed by INA. Total number of networks worldwide can be 2 to the power x. X is the number of bits used for network ID. Okay, then the host identifier. It is also a unique host identifier of y bit. Okay, assigned to each connected host in the network. In the network there is a host and host identifier of y bit. Okay, there is two IP version, as we say IPv4 and IPv6. IPv4 have 32 bit. IPv4 is a 32 bit string and IPv6 is a 128 bit string. Okay, means that here the 4 byte x plus y means network ID or host ID both become 32 bit, and here network ID and host ID become 128 bit or 16 byte. Here the representation of IPv4 address both in binary string or in a dotted decimal. In binary string there is a 32 bit 1 or 0 string 101010 of up to 32 bits. So in the binary format, but in binary format humans are not compatible with 32 bit string, so we use decimal form with a dotted representation. Here this is a IP address of IPv4 which is separated by decimal and written in a decimal form and separated with the help of dots. Okay, so and between it here each digit is of 8 bit. Here the dot is used between. Here the dots are used for each and every 8 bits. For 8 bits, here the representation of 8 bits in decimal form. Here the representation of 8 bit in decimal form. So 8, 4 times 8, there is a 32 bits. And for 8 bits, the limit is from 0 to 255. With the help of 8 bits, we can represent 0 to 255 numbers. Okay, so here what is a special IP address? A special IP address of 32 bits. It cannot be an IP address of any host in the network. Here are some special IP address which cannot be used by any host. Okay, used to represent a network. Here the network ID and host ID, two fields are used. As we see, as assigned, the network ID field is as per assigned by the IANA or any internet provider. It's providing network ID. Host ID all 0 bits. If host ID becomes all 0, then it becomes a special IP address. If there is a network ID but the host ID fields are filled with all 0, then this IP address is a special IP address. Okay. Like here with the example, consider a network ID. This is a network ID. Identify the correct decimal representation of the network address. So here, up to here to here, this is called network ID and this is a host ID. So we represent it in decimal form. So up to 8 bit, here to here, here to here. Up to 8 bit, it is 183, and up from here to here, it is a 208 and 0 and 0. So we can represent binary string of IP address into decimal dotted form of IP address. So the mode of transmission, there are 3 modes of transmission: unicast, broadcast and multicast. In unicast, one-to-one transmission means one host is sender and one host is receiver. This is called unicast. Broadcast address. In broadcast address, it is also called special IP address. Special IP address, it cannot be an IP address of any host. As we see that there is some special IP address which cannot be an IP address of any host in any network. Okay, these special IP addresses are used to broadcast a packet to all hosts belonging to the same network. If there is a network and you want to send the packet to all hosts, not any dedicated host, then we use broadcast address. How the broadcast address is looking? Let's see. Here in broadcast address, there is a network ID field is as per assigned by the internet service provider, and the host ID field is filled with all 1 bits. All 1 bits. Yes, host ID is filled with all zeros and host ID are filled with all ones. Both IP address are special IP address. From them host ID is filled with all ones are used as broadcast address to broadcast the packet to all hosts. Okay. Then the multicast transmission, one to many transmission. One host is a sender and a group of hosts are receiver. Okay, here the source IP address is host IP address and the destination IP address is multicast address. So here the source IP is host IP address and destination IP address is a multicast address. Okay, multicast address means this packet can be transmitted to all the hosts of that network. Okay, like a table key in which there is one sender and the receiver is all. So the host IP address is 32-bit, used to identify the host uniquely worldwide. As you see, so there is a network ID of X bit and host ID is Y bit. The host ID be anything except all zeros and all 1 bits. All bits were zeros and all bits 1. Except these true these two strings, means the host ID not be all zeros and all with ones. So here network size. So the maximum possible number of hosts can be in a network. Network size means that if there is a network ID, how many number of hosts can be in a network. If the host ID is of bybits, then network size is 2 to the power y minus 2. If host ID is y minus 2 to the power y minus 2. Let's see the example. Here above example. Here the considered IPv4 networks where the network ID bits are here it is a network ID and remaining are host IDs. So here the network address is what? Here this is a part of network ID and these are the part of host ID. So it is our network address where all bits are 0 is called network address, and if the all bits are all host ID, all bits are 1, then we call it broadcast address. Okay, so here it is a network address. Okay, now the first IP address of this network. First IP address of this network is this 00 is we already told that 00 is a special IP address, so it can't be considered as a first IP address because it cannot be allocated to any user. Okay, so here the first IP address is this. Now the last IP address is this, where the all bits are ones except last bit, because if the last bit becomes 1, then it become a broadcast address. So the last bits of the IP address is 0, so it is a last IP address. So here how many bits are host ID? Host ID are of bit 8 bit, 8 is 16 bit, 17, 18, 19. Here the 19 bit of host ID. So here the total number of host IP or network size, it is also we call network ID size. So total 2 to the power of, with the help of 19 bit, we can create 2 to the power 19 host, but because 00 and 11 are the special IP address and can't be used as a host IP address, so we minus 2. So the total host IPs are 2 to the power 19 minus 2. Same things here, 2 to the power y minus 2. Okay. So the network mask is a 32 bit like to IP. Network ID field all 1 bits. So in network mask, the network ID fields are filled with all ones and host ID is filled with all zeros. Here the network mask is a binary string used to produce a network address. If there is IP address, and with the IP address we have a network mask. With the help of network mask we can extract network address of an IP address. Okay, so the network address IP address bitwise AND to network mask. If we bitwise AND, if there is IP address and we do bitwise AND with the network mask, we get network address. Okay, all hosts belong to same network must have same network address. If the two hosts having same network are in same network, then their network ID will be same, like IP address, so their network ID field, host ID field, and network mask is a network ID fields are filled with 1 and the host ID filled with all zeros. And if we do bitwise AND with those, we get network ID or network address. We get network address. Here are some questions. Consider network address of given network. if there is given networks, IP address is, these are the IP address of any given networks. Identify the correct broadcast address of a special IP address. Means that we have given the IP address and we have to detect the correct broadcast address. If we plot the binary string of this IP address, so that we get this. We have extracted only these 2 points in the binary form, and these starting 2 digits we have not do this because we don't have to need. Here we see that from this point here all things are zeros, all bits are zeros, means that it must be a should be a host ID part, and in host ID part if the all bits are 0, it is a special IP address part, and if we do these bits to 1, then it become a broadcast address, special broadcast address. So here 145 75, and if we do 1111 to all these bits, it become 95 point, and if we do all bits 111, then it become 255. So this is a broadcast address. Now similar things here, consider broadcast address is special IP address of a given network. Here the given the broadcast address and then given the broadcast address and want to find the network address. So here after creating a binary string of IP address, so here we create the binary string of IP broadcast address, so we get this binary string. As we seen that in this string, there all bits are ones. Ones means these are broadcast address. So if we reverse these strings, means if we do these strings 0, then this become a network address. So after switching, we see that 175 1010 will become 165. If we consider from here, after doing these binary string to 000 now we get the network address 175 and 1010 is 1010, it become a host, so network ID part, and this is a part of host ID, so it become all 0. So its value is all 0, and this value become 1010, and these 4 bits are become also 0, so the total become 160. And if there is a 10, here is 0, if this 0 part we considered in the part of host address, because we have not given how much number of bits are in network ID, so this 0 will also considered in host ID part. So there is a network ID part is only this 101, and from 0 to this parts are host ID part. So the answer become 175.0. Okay, thank you. If you want notes PDF, you can download it from Telegram channel. The link of Telegram channel is in description. Okay, thank you.